Let's continue our recordings. So every object has some friction. Yes. Of course, our buildings also has some frictions. So viscosity is depend on the friction. Okay. So in this case, we idealized friction like a linear viscosity damper. It is proportional to the velocity. Okay. Do you know what is velocity? I already introduced you. And we have some acceleration here, and we have some displacement here. Now our formula is full with the acceleration, velocity, and displacement. Yes. So, and we will rewrite formulation using like this. If we have a u is something like this, u is equal to E of alpha t. This was before is a coefficient cosines omega n minus it was something like this, yes, before. U t was a cosine omega n t minus v blah 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 plus b u sorry b u dot omega n sine omega n t minus v, yes, and so on and so on. Okay, we can rewrite this one jointed like this. This is higher mathematics course. We can rewrite this one like this. E over alpha t, okay? This one, everything is the same, is equal to here, this one, okay? From this, I can derive u dot dot and u dot, okay? And then my formulation is going to change, like this way, okay? Can I clean this one? Upside? So here I will write u of t is equal to E alpha t. Yes? U t dot will be equal to alpha E alpha t. Yes? This is a derivative of u dot, and derivative of u dot dot is equal to alpha square E alpha t. What? Okay? If we add our formulation is the viscosity coefficient mu dot dot plus cu dot plus ku is equal to 0, yes? Instead of u, I will put e alpha t, okay? And instead of u dot, I will put alpha e alpha t power, and u dot dot alpha square e alpha t, okay? I will put everything here. Okay, m alpha square e alpha t plus c alpha e alpha t plus k e alpha t is equal to 0. Okay, if this one is not equal to 0, of course, e's power anything. If you put any number here, it is never equal to 0, okay? So, E alpha t is not equal to 0. I can neglect this one. I can remove this one. And my formulation become m alpha square plus c alpha plus k is equal to 0. Okay? It will become something like this. The solution of this formulation if you know this one, alpha square plus c over m alpha plus k over m is equal to 0, yes? Solution of this one, do you know? I think you already know. X square plus bx plus C is equal to 0. X1, 2 was equal to minus B plus minus square root of B square minus this one is yes, AC divided by 4A, if I didn't make a mistake. Yes? Yes, did you remember this formula from mathematics? And to find alpha, the solution becomes like this. Alpha is equal to minus this coefficients C over 2m. This was also square root, or I don't remember. Maybe yes, maybe no. I don't know. Yes, maybe. Plus or minus square root of C square divided by 4m square minus 4km. Okay? The solution of alpha is equal to like this. By posing, and we will find zeta. Zeta is equal to damping ratio and pulsation. This is a damping ratio, and this one is a pulsation. This is natural frequency, this is damping frequency. Okay? This is a zeta. Zeta in maximum condition could be 1. Okay? If zeta is equal to 1, damping will be 0. Okay? No? Yes? If zeta is equal to 0, if there is no any friction, our system will be damping frequency and natural frequency will be equal to each other. It means that if no friction here, our system goes natural frequency, amplitude will increase. Okay? This is how to explanation if your system comes to natural frequency. Okay? If I have a, for instance, object like this, yes. If I am moving it, sorry. Okay, it has some natural frequency, yes? If I put in natural frequency, if there is no damping, it goes up, and it collapses one day, okay? This is called if there is no damping. If there is a damping is exist. Damping will be in percentage. If damping exists, if you go, move, and it stops, okay? If small damping exists, one time it stops. If there is no damping, it is just moving forever, okay? You understand? Moving like this, without stopping. If I am just catching this damping, and with some, my external, this damping frequency is my external finger frequency. Omega n is the system frequency, okay? Natural frequency. If my omega n and this one is equal to each other, okay, this amplitude increase, okay? Step by step, okay? Like this, okay? Clear? One was the sample of this type of example. Okay, I cannot show here. It was in my PC, in my works. So, okay. So, kuch bergandan keyin to'xtamay qimirlayversa, o'sha yerda friction bo'lmaydi, ishqalanish bo'lmaydi. Agar u qandaydir so'nadigan bo'lsa, demak ishqalanish bor. Любой binoda ishqalanish bor, ishqalanish yo'qda o'sha friction coefficienti bor. Damping ratiosi bor o'sha binoda. O'sha damping ratiosi, misol uchun 5% bo'lsa ham binoda, if our damping ratio is 5%, it is also maybe good value. If damping ratio is 20%, it's very good value. After one cycle, you can neglect all signals. Agar 20% damping ratio bo'lsa, bizda binoda почти bir qimirlatgancha ishlaydi. Bino bir qimirlatishni to'xtab qoladi. Tushundingizmi? Почти yo'qolib qoladi emas. Agar 5% bo'lsa, ko'proq qimirlab, sekin so'nadi joyiga. o'sha damping ratio qancha yuqori bo'ladigan bo'lsa, bino shuncha tez to'xtaydi. 50% degan juda katta qiymat. Yoki 20% ham juda katta qiymat. 1%, 2%, 5% gacha bo'ladi damping ratio. Binoni qimirlatgan paytingizda o'sha tezroq to'xtash qobiliyatiga damping ratio deyiladi. O'sha ishqalanish uni yutaveradi. If you have brick construction, agar sizda kirpichli zdaniya bo'ladigan bo'lsa, misol uchun kirpich bilan ishqalanadida va signal yutaveradi. If you have brick construction, you have some bricks will influence with each other. There will be damping. If you have something like a, I don't know, resin or some viscose hydraulic cylinders inside the building, gidravlik qanaqadir silinderlar bo'lsa, o'sha ham demak binoni qarshiligiga ishlatishga sababchi bo'ladi. Hozir damperga bitta misol ko'rsataman. I will show you one example of the damper. It's showing or not? This is the dampers. You see that? Which remove all this movement from the building. This is it from the nearest point. This is a Asaka Bank of the Tashkent city. Okay? This is already constructed in our capital. This is Asaka Bank building in Tashkent city. There is a 30-floor building overall. In each 10 floors they install such kind of damper. Why do we need such a damper? If you are moving, if some earthquake occurs, every energy from the earthquake will be absorbed by these dampers, okay? Dampers are energy absorbing elements, okay? After some movements, they will remove all energy and the oil inside this damper will be heated up, and then all energy is going to change the heat, okay? And then our building will be stabilized after earthquake, okay? There's a reason for it. We need the damper, okay? Clear? Okay. What we have here, so we already derived from this formulation the damping ratio. I don't know, there should be the dependence after the alpha is this one. It should be. And let me clean this one. Can I clean it? Yes? Второй парад уже закончился. Не третий. Второй отлично. Это тоже есть у нас. Okay. This is a call it zeta. Чего это делает? На червяк похоже, да? Червяк называют вот эту руку. Это зета на греческом. Так, у нас C разделено 2 омега n и m. Это уже damping ratio. И у нас damping омега, натуральная циркулярная частота, омега n, 1 minus zeta square. This is our formulation. As I explained to you, this is my external force, which I am just touching to my building. It could be anything, maybe earthquake, some tractor is working here, or somebody is just breaking something inside the bricks of the building. Yes, everything is possible. If somebody is breaking the natural frequency of the building, inside the building, something, some walls, you can collapse the building even, if you have high enough force, okay? Yes, if natural frequency is the same, you can collapse the building, okay? That's why you should be very careful If damping ratio is very low, you can collapse everywhere. Okay. So, and I will rewrite the formulation like this way. So what was our formulation? It was okay, m u dot dot plus c u dot plus ku is equal to 0. Yes. I will divide everything to the m, and then u dot dot plus c over m u dot plus k over m u is equal to 0. So omega n was equal to square root of k over m. Yes? It means that k over m is equal to omega n squared. Okay? Instead of this one, I can put omega n squared. Instead of c over m, I can put yes, 2 times omega. If I product 2 times omega, it will become what? C over m. Yes? Let's write it here. 2 times zeta omega n, it will become c over n. Yes? Am I right? I will change everything. I will put, instead of this one is here, this one is also flying here and here. And our formulation will become like this: u dot dot plus 2 zeta omega n u dot plus omega n square u is equal to 0. This is our final formula of equation of motion of our object. Okay? Do you understand where it come from? Okay, we will discuss about now damping ratios. They separated alpha into complex and conjugate, some part real case and complex case, and then they derive both alphas, plus, minus something, blah 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 here, and alpha 1, alpha 2, all of them is here. And we will see some critical damping conditions and some over damping, under damping conditions, okay? If zeta is equal to 1, we are in critical damping. Critical damping means the maximum damping. Okay? Do you understand? We can remove everything suddenly. If one touch, it stops. Like if you have good absorber, shock absorber in your car, like a Malibu, I don't know, like a Japanese car or no, new Chinese car, yes? Neo or something like, they have very good suspension, yes? You are just going up, like this stops. It means that it has very good critical damping, yes? Building has also the same property, okay? Eğer maşineniz misal üçün tepedeki ötesi, amortizatorlar ve ходовой слишком четкий болса, аны өтөттөн тик токтойт сразу. Кымбат машинаның удушына коет. Маселен, например, у нас есть Huawei какой-то, Maestro или, не знаю, Neo какой-то китайский, уже старый у нас был, Toyota какой был, вы знаете, да? Квадратный какой-то модель, 80-х годов.
Не знаю.
Toyota не знаю, Toyota Crown или не знаю. Был какой-то модель, если у вас какой-то плохой дорога, короче, машина едет, баллон сам вот так играет, машина вот так, как плавно едет, да? Вот такой. Если у вас critical damping будет, типа такой будет. Все вот эти noise, сигналы, ваша система уже сам себе, как абсорбер, собирает. Хорошо? Это называется critical damping. Okay. In the case of critical damping, it will go up like this, suddenly. And this condition is over-damped system. Maybe it's impossible to find over-damped system. If we put, instead of zeta is something like a bigger number, oh, this becomes something like a complex. It's maybe a very difficult case. Okay? And there is a solution of our mathematical formulation. or we will find zeta, alpha, blah blah blah, as we know. This complex conjugate pairs, real case, ideal case, and so on and so on. Okay. So they put instead of A is amplitude. Some this is cosine, sine, as I wrote before. Yes. They put here the for formulation, and they separated C cosine dt minus phi into cosine and sine. It should be divided by omega n, but why they didn't write, I don't know. It should be. Okay. And then we have such a graph. This is a color. This is our damping. This whole our system is just absorbing energy. Okay. This is asymptote, or I don't know, asymptote, yes, we will call it mathematically, asymptotical formulation of the damping system. Whole our system is just absorbing step by step all these movements, okay? Clear? Very small, clear, yeah? Okay. And if you look, period, there is no change. Almost everything is the same. Time, period, frequency is not changing. But the amplitude is just becoming smaller, 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 okay? Frequency do not change during this type of experiment. I have such kind of condition also possible to meet sometimes. Okay, when I test the building, I have met the same condition, okay? And now I will show you. Okay, here's some of my colleagues. Okay, photo. Okay. Let me open this picture. You see that? When I have this eccentric shaker, try to move the building, it's going up, 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 and again, if I have a less than or more than natural frequency, it's going down suddenly. But now it's this graph too tight, very small stick. But if you just move a little bit longer, it's the same graph like this. That's moving like this, like this, like this, like this, okay? The same thing you can meet here, okay? It's naturally I wrote from the real building, okay? This is damping system of the building just passes through on this process, okay? What? Why you smile? Sıradaki oramız. Okay. We will go through faster on this formulation. Okay. Decay of motion is decay of motion this one. Blah 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 blah. It's moving and repeating one by one. And from this decay of motion, we can identify how much was our natural frequency, okay? Bari heading in. Немецкий язык. Гитлер капут был скоро. Okay, can I stop the camera if possible? We are speaking too much.
Structural mechanics, естественно, все это было, потому что я просто с этим работаю 20 лет. Вы волей-неволей это выучите за 20 лет, когда вы каждый день долбитесь в эти формулы. Каждый день.
Конечно.
Интегрирование, дифференцирование, линейная алгебра, матрицы, векторное умножение, скалярное умножение, тензорное умножение. И каждый день, и ты все равно это запомнишь, если ты даже хомячок. Поэтому у меня не тот случай, когда синусы и косинусы вам в жизни не пригодятся. Ей каждый божий день я в эту фигню.
Да, всем я скажу так. Мне постоянно студенты спрашивают, зачем нам синусы, зачем дифференциальные тригонометрии, вот equation to them. Я им сказал, вам будет пригодиться. Если вы структурным инженером занимаетесь, обязательно вам будет пригодиться.
В любой науке, которая связана с какими-то любыми вычислениями, математика это первое, что нужно знать человеку. Вот можно не знать вообще ни черта, но любой студент из МФТИ через год будет специалистом в любой области, потому что он знает математику, ну, как лучше всех.
И нас тоже так.
Все остальное это, все это прилипнет. Но если ты видишь эти математические формулы, если ты за этими буквами видишь смысл, о чем это речь, ты поймешь все.
Да.
Это самое главное. И самое сложное.
Повторение маточных повторяем и еще учимся мы тоже. Так, окей. We have a free vibration test, logarithmic decrement. It means that the same experiment which we did before, like this stick, or I can say something like a spring or some column. This is free. Decrement of logarithmic test is one of the examples of this one. Okay, did you see that? This is the same thing. If I put it something like this way, here, it's the same thing. Did you see that? After some time, it's just becoming lower, lower, lower. And at some point, it's very near to zero, but it never meet with zero, because always we have some motion. There is some earthquake in another corner of the earth, or some truck is just running away, maybe some train, or somebody else, maybe somebody is walking also affecting the building, okay? Everything is just affecting, but it never reaches zero, but we think that it will be equal to something like a zero. But in real case, it never be meet with zero. I have some samples. We measured some buildings with a microtremor measurement. We have some sensors. We will put on each floor like a eccentric shaker, like this. In each floor, I will put some sensors, ground, force, second, blah, 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 blah. And we have some methods. I don't remember the name of the professor of Japanese, maybe Nakamura. Yes, there is a method which is called Nakamura. You have to compare these horizontal and vertical motions to each other in order to identify the natural frequency of the building. If you have a not accuracy sensor, but you can measure not accurate sensor also the building natural frequency. Okay. If you have, of course, higher and expensive sensor, higher cost sensor, you can also easily measure the building natural frequency easily. Okay. All building always in the movement. Especially if you have some wind, maybe not earthquake. Earthquake, of course, every day not occurs. If some wind occurs every day, so you can make a measurement. In the wind also, building move, very small movement, but it's possible to record this movement using some accelerometers, okay? It's not so difficult task, but I hope we will try to do some experiment on maybe 5th floor building or 7th floor building of our university, and then we can make some analysis using some of these instruments to identify some natural frequency of the building, okay? This is one of the examples of the decay motion, okay? Now, do you understand what is a decay motion? Just free vibration. After some time, it becomes something like near to the zero, okay? Okay. It's also depend on the logarithmic some numbers, and from the previous case and the next case you will add, you will remove something, and you will measure. For instance, the previous case maybe UN and the maximum amplitude. The next case use N plus P. You can identify the naturally how much this decay is just going down, down. Okay. So this is in the case of if this one is very small value. 0.1 means it's about 10%, yes? In 10% value. Of course, for the building it's a big one, but for the formulation it's very small. If you put 0.1 here with square, it will become 0.01, yes? And then if you remove from the 1, it will almost equal to the 1, almost equal, but not equal. As you see, the 10% also how much is affecting. As I told you in my previous lecture, if we have 20% damping, is very too much. This goes down rapidly, very soon. If this is 5%, 2%, so it's high value, So this graph is going to change like this. Oh, it's going to like this, going like this way. Okay? Okay. Again, this column dam friction. We have some friction here, dry friction, and if we think this friction is something like a linearly friction, so our system will become something like this one, linearly. But in real case, linearly, maybe you will never meet. Almost everywhere is non-linearity. Something is changing with two different coefficients. Linearity is something like everything is depend on if you have some graph like this. Yes. I don't know. Maybe we have something like y is equal to ax plus b. I don't know. Something like this one. Yes. This is called linearity. If you have changed the system, something like I don't know, maybe like this. In this case, it's not depend on the linearity. Y is equal to, I don't know, maybe this side also, if possibly exists, ax squared plus b, blah 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 blah, and so on. Okay, x and plus c, so on, so on. Okay, this is called non-linearity case, because your system is not depend on only one variable value. Your system is depend on two variable values. Here is one variable, two variable, maybe 3, 4, blah blah blah. In this case, it is difficult to identify system characteristics. You have to separate all this one, partial, the differential equation. You have to identify all cases. One case is stops, like a static number. Second case is a variable. And the next one is which you take as a static will be variable in the next case. First case, which we took like a variable, it becomes a static case. It's like a partial differential equation. It's more complicated. Okay, we will not go into deeply. It's why it's linearity for us. Maybe it's enough to identify the system. Okay. Okay, and then let's go to the next part. Now we almost finishes with a single degree of freedom, and then we have to change our system to multi-degree of freedom. Multi-degree of freedom for today maybe it's a little bit heavy. For today, please, I will send to your group these all materials. Please repeat everything, and then for multi-degree of freedom, my next lessons I will try to teach you. Okay? Now matrix, and now in this case we are not going to stop with single matrix. We are going to continue single, number. There was some scalar number. Now we start with the matrix. In this case, multi-degree of freedom, 2 by 2 matrix, simple case, and then 3 by 3, blah blah blah. It's increasingly diagonally. Okay. If you have 3 floor, you have 3 by 3 matrix. If you have 4 floor, you have 4 by 4 matrix. If you have 12 floor building, please imagine you have 12 by 12 matrix. Everywhere, mass, damping, stiffness. Okay, everything is 12 by 12. You have to identify the system from this very, very, very big matrix. Okay, we are not going to reach like a 10 floor, 12 floor building, but we are going to discuss about maybe 1 or 2 or 3 floor building about some multi-degree of freedom system. Okay? Clear? Okay. See you next time. I think for today is more than enough. Thank you very much.
Thank you.
Thank you. So I will stop the recording and I will send it, if possible, to your group. This is very, very big file.